Hello friends, सबको नमस्ते. So today in this video we will create a sign language recognition mini game where the keyboard keys control the game, and the model will predict, or you can say classify, or randomly select the image and predict the, or you can say classify the image. Let me preview this. It will be a cool mini game. Wait for the seconds. Okay, so this is get started. As soon as I press S, it will randomly select one image and show me the result of that. It is K. We can compare it in using this template. Now let me press S again. Let me press S again. Okay, so this way it's working. It's a mini game which is controlled by the keyboard keys. As soon as I press Q, it will break and window will get vanished. Okay, so let me show you one thing that you can say this is a background which we are using. Okay, this is a background, and you can say these are test images which we are using, from where it's randomly select the image like this. Okay, so first of all we have to train the model and download a model. So how we can do that? For that we just have to let me upload this Jupyter file which is used for training the model. From after training it, we can easily download our model and use for our mini game. So I already open it. So this is our you can see Jupyter file. Let me connect with the GPU. Wait for a second. If I connect, terminate other session. Yes. Close it. Now connect. It's taking time to connect. Wait for the seconds. Yes, already connected. Now let me run this cell. It will download the RoboFlow library. Now this is a data set from where we can download it. So let me run it. Our data set will get downloaded. Takes time to download. So let me come back when this data set get downloaded. Okay. So our data set is downloaded. Let me show you. It's containing three folder: test, train, and valid, and each folder have a class you can say alphabetical order of folders. And you have seen that we have a three folder extra folder: dial folder, nothing folder, and a space folder. Here inside them the images is present, but which we do not require. Okay, so how we can delete this? I already created the you can say code for it, so don't worry. First of all, the main thing is that we have to change this sign language recognition minus to sign language dataset, and some files. This two files readme dataset text in this folder. Also, I am deleting it. Okay, so let me run it. After that, I have told you that we have a folder. So you can say, okay, let me, one thing is missing here. That is nothing here. And OTHING, and there will be a space. Okay, so these are the three folders name which we have to delete. This is an annotation that you can say dataset directory, and we have to make for os.list directory. It will give me the folder name, test, train, and valid. After that, I will iterate over this folders.directory. It will give me first, give me text directory. After getting the text folder name, it will give me. I will create a folder path, text folder path. Inside that folder path, I will iterate three times because I just want to delete the nothing, dial, and space folder inside each test, train, and valid directory. So I will iterate over it. I will get the path using a folder path and use the file FLT path and del path. Our deleted file folder path will get generated, and just I have to use shuttle dot retrieve and give this delete folder path, and this particular folder will get deleted. So let me run it. So let me show you that extra folders are deleted now. Our data set is ready. You can see, yes, done. Same for the train. Okay, you can see same for the train and same for the valid. So this is done. Now we have to check how many number of images is present in test train directory or in each directory, you can say. So how we can do that? Just while list directory base path means this time base path will begin you can say sign language dataset directory. You can see folder, it will give me the folder name dash train and test. After that, I will create a folder path. Then I will loop over the means folder path. After cutting the folder path, I will use the list directory. It will give me the folder name inside that. Inside the folder name, I will print a folder. Then I will get the print this OLS directory, OS path join, folder path and alpha. It'll give me the, you can say this path give me the folder name inside the train directory, test directory, or valid directory. OL list directory list all the names, image name present at particular directory. Length give me a number of images present at particular directory, and I am printing it. Alpha give me the folder name inside the train test or directory. So inside the train directory, you can see we have a number of images like this, 677, 670 odd. Okay, in valid we have this way, number of images less. Okay, in test directory this way the number of images, and you can say in okay, in train directory, number of images like 677, okay, is there. But you can say number of some images are dominating like this in the 720, 710, but here 654, 720. So we want to make that in each directory, in train directory, we want all in number of images to be the same. It's around 600. So how we can do that? So for that, I just created a code. Let me scroll down. So this is a code where I will limit train images per classes to 600. So for that, the same thing, folder path, image, os.file tool, I will directory it, and inside the folder in train folder, if I will get the folder path, I will list of all the images present in a particular directory. If image and with jpg, you will make a list of that. And if the images is greater than, if the length of the images is greater than 600, we will delete the images. Just keep the 600 images and delete other extra images. Okay, so this way we are doing it. We are just again after running the cell, and if I will run this again, you will see that uh, in train you can say every class folder have a 600 images only. So this way we are not dominating any class here. After that, we have to make a YAML file because it's required to train the model. We have to just pass a YAML file here at that time. So just path will be, you can say this is a whole string code, you can say, or you can say dictionary will be there, and train will be train, where test path will be test, valid path will be validated, and number of classes which we have is 26. This will be described, and just we have to with the open sign language detection dot and we have to first give the path data dot yml name yml file will be created. Inside that, in write mode, we have to create as file, and everything will be dump. What we have to dump? Data. This data we have to dump here in the file, and the full flow style will be false, and this way we have created a data.yml file. You can see it. Okay, so yml file is created. Now we have to import the Ultralytics, which is required to load the YOLO pre-trained model. Okay, it will take time. Now we are model which we are using is YOLO11 classification .pt. Okay, this way we load a pre-trained model. After that, we are just passing the model. We are using model to train, passing the sign language data set. Make sure it is for the classification. Now you will get confused at why there is a need of the data.yml file. Just we are just now, but here we are not passing it. So it's up to you whether you pass a data.yml file or data sign language dataset YML file. Okay, so let me pass the data.yml file. Okay, so it will doesn't show me any error. Epochs 10, it means 10 epochs will be 10, but here I'm just using a one epoch. Okay, because I already have a model which is trained on 10 epochs, so I will show you the result of that epoch. Okay, image size will be 224, batch will be 8, man, means in each batch, in one batch 8 images will be present, And you can say when you will run this file, you will get a run folder. Inside the run folder, you will get a cluster folder. Inside the cluster folder, there will be one folder which name will be decided by us, and this is the name of that particular folder. Inside that particular folder, wait folder will be there, which contain the wait file which we download. Save true, yes, we want to save every epoch. Yes, save true means we want to save the wait file. Save want to save the best epoch wait file. Patience 20 means after every 20 epoch it will see any changes in the accuracy or loss. If there will be no changes, it will stop the training and just save the best model. Validation true, yes, yes, it will validate the model also. So now let me run this cell. Showing me error. YML file error classifier must be directory data path test directory. Okay, I think so. There will be an error. Let me just pass it the direct folder name only. Oh, it's working. So this is there is no required to create a data.yml file. Okay, so don't create it. Just pass the dataset directory path and just create it. So it will just train for the one epoch. Okay, so before that, let me show you the how we can get the losses and everything. Okay, so for that you can see in cluster folder. This time you can see it's having a two folder. Why? Because first time when I run this, it created this folder name which we have decided. Whenever run the second time, it creates second folder where the current epochs or wait file will be means wait file will be there. Okay, so how we can get that? So here you can see it's after one epoch will get completed. Here one thing will be there, that is result.csv file, which contain classification log, training loss of every epoch, means it's in a csv format. So its time will be 2. Okay, now we have to first convert that. After getting the result path, we have to convert it into data frame. So here we just convert it into data frame using a pandas read csv. It will convert into data frame. After converting into data frame, we have to clean columns names. df.columns is equal to df.columns dot string dot strip. We will clean column name. After cleaning the column name, we can easily plot the graph. So for plotting the graph, if we can save the plot figure size will be 8 by 5. What we have to plot? We have to plot df training loss. We have to plot marker 0. Okay, means we have to mark each you can say point value. You can say which value we have to mark 0, and title will be the string. Font size will be 40. X label will be epoch and Y label will be loss. Grid will be true, yes, and plot so. And same for the accuracy. Okay, this time it is training for the one epoch, so it will does not show anything, but you can see it is a result for the 10 epoch. Okay, so this is the working. And after for checking it, we just have to give you a wait file address, then the folder name is this time it a test directory. It will first load all the list of the images present in particular test directory. You can see in test, you can say folder name will be there. So I have to make some changes here. So how I can make it? So let me, okay, get list of image files for images folder. Okay, yes, is image folder. Only it will get the image folder names abcd efg till z. Then we have to plot 16 images. So plot dot subplots 4 images or 4 rows and 4 columns. Each figure size will be 16 by 16. Here access is in a 2D format and Excel table. After using it, it will convert into 1D format just for the easiness of iteration. We have to plot 16, so 4 will be 16 time. Random choice image folder means it will randomly select whether randomly select A, B, C, D, E, F, G, H folder name. After selecting randomly select the folder name, it will give me the image file. For that we have to use OLS directory os.path, means we have to first get the image file name inside a particular directory. For that we have to use os.path join test image folder name, means this one, And after that, the randomly select the folder name. We will get number of images present in a particular directory folder in ABCD folder. After that, we have to create the image file. For that, we have passed the image test image folder which is randomly selected, and the randomly choice the image file. This way, we create the image path. We have to reading the image path, means after reading the image, we just pass the image, and we will get we are passing the single image for, so to get the single image, you can say single image prediction, just use a zero index value, and result.prop.top1 give me the class id. After getting the class id, model name, and just give the class id, will get a class name. Confidence, result.prop.top1 confidence item, give me the confidence here. After that, after getting the confidence here, we just convert the image into RGB, and after that, just we have to plot it. Just actual will be the image folder, just randomly select the image folder will be the actual prediction, and predicted by the model will be the class name, and here we display the confidence. Okay, so I think so training got completed for the one epoch. You can see where it's gone. I think so. Inside the train folder, I think so. Connection problem will be there, so don't worry. Okay, so this way training will completed, and inside the run folder you will get this csv result.csv. Okay, now let me upload the model which is trained on to a tiny epoch and show you the result of that model. Okay, for that, bash.pt, open it. Okay, it will take the time, so let me come back when it's completed. Okay, so here's a run folder. You can see that in classify this here, after first epoch completed, you get as result of csv. Inside this, every epoch accuracy and loss is there. Okay, so now let me run this. Okay, okay, it's does show me nothing. Okay, just one value will be there. Now let me show you the result of the model which is trained on one epoch. Okay, now let me run it. See the result of that model which is trained on just one epoch. Prediction UYI55 PPCC. Yes, it's working very well in one epoch also. Okay, okay, it's working very well. Till now, it's working very well for one epoch also. Okay, but this is a model which is student 10 epochs. Okay, so this way you can download it. You have to download the model here. Okay, from here. From here, you have to download the model. This is the model which is showing 10 epochs. Let me show the result of this. I think so the result will be similar because in one epoch it's predicting enough good. Okay, so you can download it. So let me come back here for the main on a main code. After that, you have to upload your model here. Then our main thing gets started. The first step is that to see this is a background. So to we have to first make this background static and apply this start and queue start and queue means keyboard activate the keys functionalities. So let's get started. For let me first comment extra code. Let me come back with commenting the extra code and just be our main code which we have a first step. So let me come back. So let's get started. So this is you can say the folder name. You can say the directory. The frame will be there. It will read the image. Just read the background. Then if it is frame is none, it will throw the error. Then we have to use the while loop. Okay. See key is equal to cp2 wait key means 0. Capture key press means it wait till the key is pressed. Okay, and it will show the image frame. Okay, as soon as I press S, as soon as I press S, it will randomly select the choice folders. You can say from folders, from text directory. You can say in alpha label we have a number of images, so it will select from number of images from list of all the images. It will select randomly select one image. Okay, this is a text directory and this is a alphabet directory. Text directory, this one. and this is the alphabet label. So don't see this. This is an alpha label like this one. Okay, so this one. Okay, this one. This is the labels which we are using. The text directory is this one. Okay, this one, from where we randomly select the folder name. Okay, after selecting randomly select the folder name, it will just create the path of that alphabetical path, whereas a path then text directory, then the subfolder. Randomly select the folder name, this the folder name is collected, alphabet path is created. After that, we have to make the list of all the images present in that particular folder. Suppose randomly select the folder name is O, so it will make the list of all the images, list of all name of all the images present in a particular O folder. After that, it will select randomly, it will randomly select one image name, and using of that image name we will create the path of that. After creating the path of that, we will just read that in particular image and resize it to 448 and 446. Why 448 and 446? Because you can see, you can see this dimension, this box dimension is 448 and 446. How I know? Because I created in a canvas. As soon as I press Q, it will break the loop and everything will get vanished. And if suppose I will press other key from Q and S, it will throw me this, it will print in a terminal, print as start for Q to stop. And after this I will just destroy all the windows. After I will Q will press, while loop will vanish, and it will destroy all the window which is created. Now what is the main thing? We will just load the model which we have downloaded. Okay, after downloading which we have downloaded, you can see which we have trained on a custom data set using a overflow data set. So we will load that model. After randomly select the image, first we have to pass it to the model. Okay, it will after passing it to the model, it will give me the result 0, and you can see result 0 top 1 give me the class id. After getting the class id, I want to know the label, so this way I will get the label. Okay, so after getting the label, we have to select one label from this alphabetical label folder. What, see, this is how we can say these are the labels which I have already. A, B, C, D is are the name. So after getting the label, I can easily get the label image path. Just use alphabetical director and this label.png. You can see everyone is a PNG format. Just read that image. Okay, after that, this one is this one. Means if suppose label image is not there, it will throw the error to me. Okay, if label image is none, it will throw me error or print this, or we can continue it. After that, I want to resize it in this format, in this size. Why? Because you can see we have to display this result here, so we have to resize it according to that. So this is the size of that. After that, it will check that check if our background is large enough or not. After checking, we have to shift. See, these are the coordinates values. We have to in frame, in suppose this particular frame, these are the coordinates values. This is a number of rows from here and number of columns from here to here. I already calculated it. After calculation, just pass the image, means image this one, which I have randomly selected from the text directory. And just same way, place predicted alphabetical, the alphabetical which is predicted by the model which is placed here. Okay, so this way we you can say crop place the label and the image which is randomly selected, and after that we are just show the frame. So this way we are working, this way the whole code is working. Now let me run this so that we can preview it. Run it. It will take time, please wait for the seconds. As soon as I press S, it will randomly select one image. I press the S. Okay, so An, where is this An? A, An is this one. Similar to An, let me select one S again. Press S again. This is W. Yes, it's W. Okay, then S again. This is V. Yes, it's V here. And let me U. Wait, is you? Yes, it's you. So as soon as I press Q, every window will get vanished and everything will get stopped. So this is a very simple language recognition mini game which we have created. We have trained the model. We have created using this background. We have created one mini game which is controlled by the keys. Okay, so this way you can make it and enjoy the OpenCV. So please like, share, and subscribe. Thanks to all.